Okay, let's quickly review how to graph this stuff because I know that this unit has a lot to it. Okay, let's make sure we would be able to graph sine and cosecant. Because remember, if I said to you, graph y is equal to 2 cosecant of 2x, you would rewrite it like this, wouldn't you? And you'd graph that first and then use that graph to graph cosecant. So how you would start on the test is you would say, okay, I'm going to make an xy chart here, and I'm going to go ahead and do the parent function for sine of x. So we would go around the unit circle, 0, pi halves, pi, 3 pi halves, 2 pi. For my parent function, I'm always usually only going to do the one cycle, but when graphing it on the test, I'll do 2 cycles. So then right here, if we remember the cycles, the pattern for sine, it's 0, max, 0, min, 0. Does everybody feel good? Okay, so now let's go through and say what our shifts are, or what the changes we need to make. Amplitude of 2, correct? So we need to take our y values and times them by 2. And then we got to change our period. So period for sine is 2 pi divided by b. So it's 2 pi divided by 2, which is pi. Now everybody look, we are ending at 2 pi. We need to end at pi. So what are we timesing our x values by? 1/2, which is the reciprocal of b, which we've seen that pattern happening over and over. So let's write down our official new xy points. So we would have 0 times 1/2, 0. Then we're going to have pi fourths. Then we're going to have pi halves, 3 pi fourths, and then we'll have pi. Now let's continue. This is what I would do on the test. I need to do 2 cycles. So think about it. If I have another cycle, where am I going to end? 2 pi. Let's fill in the rest. After pi, it's going to be a pi fourths, isn't it? So it's going to be a 5 pi fourths. Then it will be 3 pi halves, won't it? And it will be 7 pi fourths. And then we're there. So then from here, we would do 0, now 2, 0, negative 2, 0. And then just fill it in. 0, 2, 0, negative 2, 0. Wow, I really wrote big. I needed some room to draw. Okay, well, I guess I'll try to fit it right here. Alright, so let's fit in, so you would have pi fourths, pi halves, 3 pi fourths, pi, 5 pi fourths, 3 pi halves, 7 pi fourths, 2 pi, amplitude is 2, and then we're going to graph our sine. See how there's plot points at this point. And then make sure on the test you draw nice pretty round curves with an arrow at the end because we know it continues, and there's sine. That would be perfect full points. Now for the cosecant, what you would do is you would be at this point, and then you'd say, okay, we know that cosecant is 1 over sine, so we cannot divide by 0. Therefore, wherever our sine is 0, we need to put in vertical asymptote. It is 0 right there, right there, right there, right there, right there. So you would go draw in with a highlighter on the exam your asymptotes. Then from there, remember reciprocal, we just got to reciprocate smiles to frowns. So right here, this point and this point would be the same, and then it would become a frown to a smile. This point and this point would be the same, frown, smile, frown. And we have 2 cycles drawn for cosecant. So look, a cycle for cosecant was a smile and a frown. Right, everyone? And that was not that bad as long as you know what you're doing. Everybody feels pretty good. Okay, let's go over quickly tangent and cotangent. Couple key things to remember going into the exam. So you should first say, okay, I didn't teach this one by parent function because I thought that made it harder than it needed to be. So what you would say on the test is you'd say, okay, I see I'm graphing a tangent. Key things to remember is that tangent always has vertical asymptote split over the y-axis. And this right here, from here to here, is the length of a period, correct? 1 period. So then I'd say I just go in, draw my XY chart here. Then I would say, okay, my amplitude is 4. And then I would go draw my asymptotes next. So I would just do split here perfectly. And I need you to do 2 cycles, let's say. So then from there, we got to fill in our x-axis. So from here to here is a period. I would always on the test go write this in, kind of draw this in. This is the length of a cycle, a period. For tangent, it's pi over b, so pi halves, correct? Now that full length is pi halves. People kind of have a tendency to do negative pi halves and pi halves, but that wouldn't make sense. From here to here is pi halves in length. So draw that in if you need to. So then split evenly would be negative pi fourths to pi fourths. Now you're doing pi fourths plus pi halves, and you get 3 pi fourths. The next thing I would need you to fill in on your x-axis is the in-between, the 0. So how would I find the middle? You would add up these 2 numbers and then divide by 2. So that'd be 4 pi fourths, which is pi, and then we got to divide it by 2. So this point would be pi halves. And now I filled in enough on the x-axis, and then you would remember tangents increasing. So in the middle it crosses is the 0, and then it sends tangents increasing between the 0 and the asymptote here. It'll be down at the amplitude. Between the 0 and asymptote, it'll be up at the amplitude. And that would be full points. Everybody good? One more, then we'll get on going on today's lesson. Cotangent. So once again, once you get to the test, and I'm going to actually make, like a saint that I am, I'm going to make a little paper that says key things to remember for exam, because there's going to be quite a few for this exam. Won't that be so nice? Yeah, I was looking for that. Hey, you're welcome. I was like begging for a compliment. Okay, you're welcome. Okay, so what you do is for cotangent, you'd say, okay, I need to remember that cotangent's asymptote doesn't split evenly, but starts at 0 and goes over. And then this from here to here is the period. So now you'd say, okay, my amplitude is 1. And then you would go ahead and find your period, which is pi divided by b, which is pi divided by a half. So that'd be 2 pi. So I'm going to give you a highlighter on the exam. You'd start at 0. Did you see how I almost didn't start at 0? I almost went and split. You got to just be really careful, because even I just almost did it. So from here to here is 2 pi. So obviously that would be 2 pi, wouldn't it? No. And from here to here would be 2 pi. So that'd be 4 pi. So then halfway between here would be pi. Halfway between here would be 3 pi. Then you'd say cotangent is decreasing 0, 0, halfway up to the amplitude, halfway down the amplitude, and voila. Okay, hopefully that helps to remember how to do that stuff from last time. Let's get going on today's lesson. I'm having a hard time speaking for some reason. Okay, unit circles are going to be really useful. So what we're doing today is we're going to be talking about using inverse trig functions. Now I'm going to graph it, but I will not ask you to reproduce the graph of this. Why I'm graphing it is to help you see why we have restrictions on input and output for sine inverse. So don't worry about graphing it. You can kind of just watch to begin with, unless you really want. So just remember, guys, inverse sine is not the same thing as cosecant. People think that. I always have people say, so cosecant is the inverse of sine. No, no, no. Cosecant's the reciprocal of sine. Sine inverse is completely different. Okay, so let's look at y equals sine of x. I've written down some xy points. Notice 0 pi halves pi, 3 pi halves 2 pi. I've written down one cycle here, plus an additional point. And we'll talk about y in just a second. And then this pattern for sine, 0 max, 0 min, 0. So that was 2 pi, sorry. Okay, here is my sine graph, agreed? There's one cycle for sine. Okay, now we have these xy points. Isn't it true for inverses, if I said find the inverse of this set of xy points, that we could just switch them? Switch x and y, that's how we find inverses. So let's start here. Switching 0, 0 would be still 0, 0. Switching 1 pi halves. Then we would switch 0 pi. Then we would be switching -1, 3 pi halves. And then 0, 2 pi. So everybody looking at my inputs, what will my x-axis be for sine inverse? Between what? Look at your x's inputs, everybody. 0. And then -1 and 1. 1, correct? Aren't those the only inputs we're going to ever have? Okay, yes. So there's my x-axis labeled. And now my y-axis is this. Now think about it. If we turn our head like this is what we're going to be looking at technically. So our y-axis is this now. So right here would be pi halves, pi, 3 pi halves, 2 pi. And then technically I could go down 2 as well, correct? Negative pi halves if I so desired. And so on. Okay, so let's plot some points here. 0, 0 is my first point. Check mark. Over 1 up pi halves. This would then connect to here. I drew that the wrong curve way. Sorry, that was a weird curve. I should have gone more like this. Sorry, that's going to bug. I'm a perfectionist. Just ignore me. So like this, and that was pi halves. Alright, so that's a better curve, do you agree? So we're going to continue. And then over 0 up pi, continuing, and then over negative 1 up 3 pi halves, and then over 0 up 2 pi. You guys see it? Awesome. Now, let's go back a point, just for kicks and giggles. So if we were to continue the pattern, we know if we were to go continuing the pattern, it would be at negative pi halves and negative 1. So switching that would be negative 1 and negative pi halves. So we also have this point, negative 1, negative pi halves, and now connecting it. All right. Now, don't you guys see a problem here? Does this pass the vertical line test? No. It is not considered a function based on what we have drawn. We have too much drawn. Basically, we've got to restrict our outputs. Otherwise, it's not a function. So let's look here. If I'm tracing along here, do you guys... So I'm tracing along, tracing along, tracing along. Now, starting with this point, aren't we double dipping? All this stuff's double dipping. So we can't do any of these points. We've actually got to erase some and say, okay, we're going to restrict our outputs to just these values. Because now it passes the vertical line test. Okay, awesome. So sine inverse is going to have inputs between negative 1 and 1. We can only plug stuff in to sine inverse between negative 1 and 1. Can I plug in 2 then? No. Okay, good. You're right. Okay, and then our outputs, our y values, our answers have to be on the interval from negative pi halves to pi halves. We have to put all of our answers in that interval. Anywhere else, it's in the double dipping part. All right, so this is that same slide just kind of put into pretty view here. The domain for sine inverse negative 1 to 1. The range is negative pi halves to pi halves. So everybody, when we answer sine inverse, when we'll talk about what it means in just a second, we have to do quadrant 1 and negative quadrant 1. Now technically, quadrant 4 is negative quadrant 1. Agreed? But quadrant 4 is actually clear up here in the loop-de-loop. So we actually have to answer, instead of as quadrant 4, as negative quadrant 1. So instead of calling this 330 degrees, we have to call it negative 30 degrees. Does that make sense? And negative 45, and negative 60, and negative 90, not these values. Okay. Right? Let's talk about what sine inverse means. Everybody write this down in your notes. Sine inverse with a negative 1 is the same thing as saying arc sine. They mean the same thing. You can see it written either or way, but they mean the same thing. Now, what sine inverse is saying, whenever you see sine inverse, this used to confuse me until I started to actually say it, what it means to myself, every time I see this. So when I see sine inverse, I literally just read it to myself. This is asking me, what angle will have a sine of that value? Or, now remember, sine is y values, so this is literally saying, what angle has a y value of whatever number is in here? Now, if you look down in your unit circle, here are our y values, we're just going to be finding the angle. So it's actually backwards of calculating sine of pi fourths. Sine of pi fourths is not inverse. It says sine of pi fourths. We would go to pi fourths right here. And then the sine is the y value, so our answer would be root 2 over 2. Agree? Okay, now this says, I'm going to write it out this one time, what angle has a y value of root 2 over 2? Do you guys see what sine inverse means? It's just going exactly backwards. So what angle? 45 degrees. It's just going the other way, backwards. Does that make sense? Now we could say 45 degrees, or we could say pi fourths, same thing. And on the test, it will say answer in radians or degrees. So right now we'll just practice writing down both. Okay, now understand once again, with sine inverse, remember we have to answer, these inverses have to be answered from pi halves to negative pi halves. That's super important to remember. Okay, let's practice then. So this says, what's the angle that has a y value of negative root 3 over 2? 5 pi thirds, but we have to remember we can't answer it as 5 pi thirds. Yep, negative pi thirds. Or negative 60 degrees. Does everybody get how to do it? Awesome. Okay, let's answer this one right here. What angle has a sine of negative 1? Now sine is y value, so this says what angle has a y value of negative 1? 270, and we can't answer it as 270. We have to call that negative 90 degrees. Or negative pi halves, however they ask you to answer it. Is that kind of making sense? Okay, awesome. What the heck? I swear I skipped a slide. I did. Okay. All right, I wanted to do a couple before I got to that next one. Angle who has a y value of negative a half, answer it. Negative pi 6 or negative 30 degrees. Same thing? Good. What angle has a y value of root 3 over 2? 60 degrees. Okay, I think we're getting the picture. What angle has a y value of 2? None. Okay, why do you say that you're right?
Because it's between negative 1 and 1. It doesn't go over.
Perfect. Inputs can only be between negative 1 and 1. Aren't we trying to plug in 2 right now? Yeah. Can't do it. That's out here. Can't do it. Okay, so none. Very good. Way to go. Okay, now write this down in your notes, please, everybody. There is a huge difference between this problem and this problem. So write down. Difference between this and this. Now this one says, what sine inverse is, what one angle has this y value? This is, however, not saying sine inverse. Sine inverse has this graph right here. But this sine of theta has the graph that looks 0 max, 0 min, 0. That goes on forever. So this is going to have multiple answers, where this will only have one answer between pi halves and negative pi halves. You guys see how this is not sine inverse? So this is saying what angle theta will have a sine of negative root 3 over 2. So what you're going to do is go around the unit circle the first time and we'll answer it that way. So starting at 0, find a y value of negative root 3 over 2. That happens right there, correct? So we would write that down. Theta equals 4 pi thirds is our first answer. Now let's keep going. And theta also equals, continuing, you said, right here is the next one, 5 pi thirds, because it's the y value. You guys agree? So also 5 pi thirds. But now we know that sine has a domain of all real numbers. Can't I keep going around that unit circle? As I go around, once I'm back to here, it's the answer again. Once I'm back to here, it's the answer again. So isn't it all the coterminal angles as well? So then we would just put plus and minus 2 pi n. That means we can add or subtract 2 pi as many times as we want, and that will also have a sine value of negative root 3 over 2. So we'd have to add plus or minus 2 pi n here. So just make key note of that. If it doesn't say sine inverse, then you're going to have multiple answers. If it does, then that's restricted. All right. You guys are doing really good. Okay, now a couple things people kind of get confused on, and so I need to go over it. Obviously, sine inverse of a half is super straightforward. It's pi 6, right? Okay, now right here people will see this and they'll say arc sine of pi 6. What they'll do is they'll just treat it like it's saying sine of pi 6. What they'll do is they'll say, oh, so sine of pi 6 is a half, and they'll answer it as a half. But this is not what it's asking. It's asking, what angle has a y value of pi over 6? Now look at your y values. Aren't these not in radians, but like they're like exact answers here? Now there are decimals in between here. So is pi 6 an actual number we can plug into our arc sine? Is pi 6 a number between negative 1 and 1? So if you need to, type in your calculator pi divided by 6 for the video for me so I can write it down. This is kind of similar to saying arc sine of what decimal? 0.55. Do you guys see how it's okay to put that 0.55 into our arc sine? Isn't that okay right here? Look, 0.55, isn't that going to be about right here somewhere? So we've got to figure out this amount right here, something. Now it's not going to be an exact answer like on our unit circle, because that's not on the unit circle. Do you guys see? So this is the one time, since this is not a value on the unit circle's xy points, where we will be able to type it into our calculator. So make sure your calculator is in radian mode, and because this is not on the unit circle, you can just type in. So hit second sine. I want everyone to do it. Make sure your calculator is in radian mode because you're inputting a radian. And then hit second sine of pi divided by 6, and then that will give you the how high up it is, the decimal. Oh, was this not 0.55? Oh, okay. 0.52, sorry, which is still in the input. So this was 0.55. Our answer is 0.55. So general rule of thumb, if you cannot use the unit circle, then you'll just use your calculator. All good? Okay, let's go on to cosine inverse. So everybody just, once again, the graph is only going to help us know the restrictions on our input and output. So here's cosine of x, so same idea here. Okay, there's one cycle for cosine. Here's those points. To find cosine inverse, I switch them. 1, 0, 0 pi halves, -1 pi, then 0, 3 pi halves, and then we're at 1, 2 pi. So look at your inputs for cosine inverse. Same as sine inverse. It's between -1, 0, and 1. And then the y-axis, same idea. So here's pi halves, pi, 3 pi halves, 2 pi. Okay, let's start plotting points here. So over over 1 up 0, over 0 up pi halves, so connecting this through here. Over -1 up pi. Has there been any problems yet? No, all is good. Now let's see if we need to keep going here. If we go over 0 up 3 pi halves, that's right here. Now aren't we double dipping? So we just stop. That's restriction was a little bit easier than sine, because now we won't graph that stuff. So the inputs for cosine inverse are between, same as sine inverse, -1 to 1, but our outputs for cosine inverse aren't from negative pi halves to pi halves, but instead from 0 to pi. So we're going to have to remember that. So here is cosine inverse, that same idea like I said for sine, just written in general. So just a reminder here, for cosine inverse, our outputs are going to be in quadrant 1 or quadrant 2, where for sine inverse it was quadrant 1 and negative quadrant 1. Something you kind of have to memorize going into the exam. All right, so let's practice that. We're doing really good. We're actually flying through this lesson. You guys are doing awesome. So what angle, now cosine's x, keep in mind, what angle has an x value of √2 over 2? 45 degrees, agreed? Now, once again, guys, look, there's another place that happens right here, but that's not in the available output for cosine inverse, so we wouldn't answer that. Angle whose cosine is -√2 over 2. It's an x value. 3 pi fourths. Pretty straightforward. Angle that has an x value of -1. Pi, or 180 degrees. Does everybody see? Okay. Angle whose x value is -1/2. 2 pi thirds. We have an angle whose x value is pi. Isn't pi 3.14? So what would I do here? None? You're right. Why are you saying that? You're right. Perfect. We can only plug in from -1 to 1. 3.14, clear out here. There is no graph for that, so none. All right, now tangent inverse, I'm going to cut right to the chase. Here is tangent. Remember, tangent here is we have a period of pi. So here's pi. I split it evenly from negative pi halves to pi halves. Those are my asymptotes. And I've now flipped it, my xy points, and there's tangent inverses graph. So what do you notice about tangent inverses domain? I can plug in anything. That is different than sine and cosine where we're restricted from -1 to 1. But the outputs for tangent are between pi halves and negative pi halves, which is actually the exact same as sine. Quadrant 1 and negative quadrant 1. The only difference is, with sine, there is a point at output of negative pi halves and pi halves. But tangent has asymptotes there, so there is not an output of pi halves to negative pi halves. That's why I have parentheses versus brackets here, because that's not included in tangent inverse. So this was what you're going to have to remember. Once again, quadrant 1 and negative quadrant 1 are our answers, our outputs for tangent inverse. All right, so practicing here. Now, I was going to go through and do all the math, but we are pretty good in this class to already have it memorized. Let's go through and remember what the tangents are at each of these values here real quick. So the tangent at this would be the y over x, so wouldn't that be 0? Tangent here is 0, tangent here is root 3 over 3, tangent here is 1, tangent here is root 3, right here it's undefined, agreed? So that's the no. We can't be that, which makes sense. So then this would be negative root 3 over 3 at this angle. This would be negative 1 and negative root 3, and then this is undefined. All right. Okay, let's answer that then. What angle has a tangent of root 3 over 3? 30 degrees. Agreed? Okay, good. What angle has a tangent of negative root 3 over 3? Negative 30 degrees. What angle has a tangent of negative 1? Negative 45 degrees. True. What angle has a tangent of 0? 0 degrees, or 0 radians. Right? That was the one we decided was 0? Okay, cool. You guys are doing so good. Okay, just maybe take a picture of this graph here. This is just showing you in general, because this is the mental picture you're going to want going into the test. So sine inverse looks like this, cosine inverse looks like this, and tangent inverse looks like this. More importantly are not the graphs necessarily, but remembering sine inverse and tangent inverse outputs are in quadrant 1 and negative quadrant 1, where cosine inverses are between 0 and pi. Then also just remembering, once again, inputs for cosine inverse and sine inverse are between -1 and 1, where tangent inverse we can plug in anything. Okay, let's do like the big whammy schwammy. They start putting stuff together. All right, so I might want to, if I was you, maybe write this one down. I'm going to shrink this a little bit. All right. Now, it's just, guys, this is just calculating things on top of things. What you're going to want to do is always work from the inside out. So let's go through and do this here. Let's calculate. Now, this says, what's the cosine of 2 pi thirds? So we're going to go to 2 pi thirds right there. And then cosine is the x value. Agree? This isn't cosine inverse. This is just cosine. So the cosine at 2 pi thirds is -1/2. So now we've answered the inside. So now we're just starting with a new problem. Cosine inverse of -1/2. So now you would start your brain over and say, what is this asking me? What angle has a x value of -1/2? 2 pi thirds. What happened here? Yeah, inverses undo each other, don't they? So these undo each other. So we got 2 pi thirds. Now don't be the person on the test that says, so this is 4 pi thirds. So this is root 2 over 2. Not necessarily. Not necessarily. And let me show you why. Okay, it'll make sense once I show you why. So let's do this one from the inside out here. So cosine of 4 pi thirds, I'm going to locate 4 pi thirds right there. Cosine is the x value, so now we would answer that and we get -1/2. So now we're asking cosine inverse of -1/2. Now we're doing an inverse. Don't we have restricted output?
Yeah.
Can it be down here?
No.
No, so we can't answer down here. My answer is going to be the angle whose cosine is -1/2 is 2 pi thirds. So look, that one did not just cancel out. Does that make sense? So can anyone maybe by chance put it into generalization form here? When could we possibly just cancel them out versus when we couldn't?
When it's within
it's within the correct place, then you can go ahead and just cancel them out. But if it's not, you gotta think a little bit. Let's say you forgot that though, just do the math, it'll all work out. Okay, let's do this one. Cosine of cosine inverse of negative root 2 over 2. Let's start from the inside out. This says what angle has an x value of negative root 2 over 2? Now we know we have to answer up here, don't we? And only up here, so our answer would be 3 pi fourths. So now we're doing the cosine of 3 pi fourths, and that would be the x value, which is negative root 2 over 2. Now did that one just cancel out? Yes. Now if the cosine inverse is on the inside, would it make sense that it would be okay for it to always cancel out?
Yes.
Yes. Can you explain why? Because I didn't do a very good job last hour of explaining why. Yeah, there's only one. Perfect. There's only one possible answer. We're going to answer it correctly, the cosine inverse, right? And then won't the x value be the correct thing if we undo it? I suck at explaining that. I can't deny that. Okay, awesome. If you don't get that, then just calculate from the inside out. I'm sorry. I'm trying my best here. All right, let's keep practicing these. All right, so there's a couple of little key things to note here. So arc sine and sine of 3 pi halves. Could I just cancel these ones out? Nope, because 3 pi halves is not in the arc sine availability. Agreed? Okay, so let's just calculate from the inside out. The sine of 3 pi halves is dot, 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 the y value. So what would it be? Negative 1, wouldn't it? Right here? So now we would say arc sine of negative 1. Sorry. Arc sine of negative 1. What angle has a y value of negative 1? Negative 90 degrees. Perfect.
Couldn't you also say negative pi half?
Yes. And it will tell you on the test. Answer in degrees already. Okay, so let's look at this one. Can I just cancel these out? Yes. Arctan of tan. Now, yes, if the inverse is on the inside, you can always cancel it out, only if you can actually calculate this. Can we plug in anything into arctan? Yes, this is the one that doesn't have any restrictions for input. So yes, we can just cancel out. Inverses undo each other, so negative 5 would be my answer here. So what people do, though, is they look at something like this, and they think that they can cancel out. They say that if the inverse is on the inside, it can cancel out. True, 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 true. But if and only if you can actually calculate this. Can we calculate cosine inverse of pi? No, because that's find an angle, and we're inputting 3.14, which is not in the interval from negative 1 to 1. You can't do that, so you can't do that, so nope. All right. I know. Okay, so sine of 5 pi thirds was the y value, negative root 3 over 2. So now find arc sine of negative root 3 over 2, everyone. Negative 60 degrees. Everybody good out there? Okay. You are doing awesome. We're actually we are going so quick. We're winding down. Okay, the last couple examples. I want you to write this one down. Okay, I'm telling you what's on the test. This problem is going to be on the test, just different numbers. And even though I say that every year, seriously, 30% of students miss this one. And it's not hard. So write yourself a note. This is on the test, says Miss Christensen. All right. Now understand here, we would check. So it's arc cosine and then tangent on the outside. Now arc cosine, we know we have to be able to plug in something only between negative 1 to 1. And 2/3 is like a decimal that is between 0 to 1. So we're all good there. Now notice this is not an exact x value on our unit circle. Do you see that anywhere on the unit circle? No. So instead what you're going to do is you're going to draw, because this is not unit circle trig, this must be right triangle trig, which makes sense. If we have a fraction, wouldn't it make sense that this is saying you have an angle with cosine of 2/3. So let's go ahead and draw a right triangle. You put in your 90 degrees, put in an angle. It says you have an angle with a cosine of 2/3. Cosine is adjacent over hypotenuse. You guys see how this and this mean the same thing? And now you would have to just do Pythagorean theorem to find this side. So you would do 3 squared minus 2 squared equals side, that's a side, side squared. So then that would be 5 is equal to side squared, so root 5. So this is root 5. And now this literally says find the tangent of that triangle. Tangent is, oh heck, another hour of agony. It's opposite over adjacent. So my answer would be root 5 over 2, and done. What a shame it would be to miss something of that caliber, because that was not that bad. Let's do one more like that. Would you prefer to try it by yourself? Yes. Okay, sweet. Check your answer when you're done. Were you able to get the forefus? Awesome. Okay. Okay, everybody. Now we're going to see where we're going to just throw in a variable. But guys, math doesn't change. It's the same thing. And I'm telling you, there is going to be one. I'm telling you, there's going to be one with a variable. So maybe write that. I'd write that in my notes, but that's just me. All right, so guys, math doesn't change just because there's a variable in it. So this says we have an arc cosine, a sine of an arc cosine of 3x. So you'd say I have an angle that has a cosine of 3x. Well, that's obviously not on the unit circle, so this must be a right triangle. So we would call this 3x over 1. So now you'd say I have a right triangle, and then I put in an angle. I have an angle that has a cosine of 3x over 1. Cosine is adjacent over hypotenuse. So my adjacent is 3x, my hypotenuse is 1. Now to get this side here, we would set up a true statement, 1 squared minus 3x squared equals side squared. So that's 1 minus 9x squared equals side squared. So we would square root. So then our side is 1 minus 9x squared. Now the square root of 1 minus 9x squared. Could I, if I wanted to write that as 1 minus 3x? No. You're right, absolutely not. If we do that, that's bad. Calculus will be really hard for us if we do that in calc. So that's breaking the forbidden rule, isn't it? It's a subtraction sign. You can't just 1/2 that, 1/2 that. So deep, don't do that. Okay, now find the sine. Sine is, oh heck, isn't it? So that over that. So we do the square root of 1 minus 9x squared over 1. So your final answer is the square root of 1 minus 9x squared. The math didn't change. There was just a variable thrown in. Now it just says find the cotangent of cosine of 3x. Same right triangle, notice. I've done the same right triangle, so we don't even need to redo it. We're just going to we already have our right triangle. Here it is. This is find the cotangent of So cotangent is, what cotangent is? Adjacent over opposite. So that'd be 3x over the square root of 1 minus 9x squared. And then that's your answer, but it's not an appropriate answer. So we would rationalize our denominator. So what's on top? And then on bottom, don't say it's nothing, because it is. And then are we done? Yep, good catch though. I'm glad you caught yourself though. We can't divide across subtraction signs, so this would be our final answer. That wasn't that bad. And that is the end of the lesson. So go ahead and start working on the homework.